Good morning and welcome. This is Mission Control Houston. This morning, a Cygnus cargo spacecraft supporting Northrop Grumman's 18th Commercial Resupply Services mission, which launched from NASA's Wallops Flight Facility on Monday, 4:32 a.m. Central, 5:32 a.m. Eastern. Cygnus successfully completed its milestones immediately after launch, including spacecraft separation and orbital insertion. After our coverage concluded, Cygnus attempted to deploy its solar arrays. It successfully deployed one wing, but received indication that the second wing did not fully deploy. Ever since, teams at Northrop Grumman have been assessing the non-staged solar array, and it's believed that the solar array made it to a partially staged configuration, partially deployed. To remain focused on the spacecraft's arrival at the space station, Northrop Grumman and NASA made the decision not to deploy the second solar array after initial attempts to deploy were unsuccessful. Teams expect to get a better view as the spacecraft approaches the International Space Station and do plan to take additional imagery of the spacecraft. Getting live views now of Northrop Grumman's flight control room in Dulles, Virginia, as Cygnus continues to approach the International Space Station. Cygnus does have sufficient power to rendezvous with the space station, and its deployed wing is able to power the spacecraft, recharging in an orbital daytime. Back with you here in Mission Control Houston with live views. Today's rendezvous and capture is a dynamic event, but if all goes according to plan, we expect a capture at 4:05 a.m. Central, 5:05 a.m. Eastern at the controls of NASA astronauts Nicole Mann and Josh Cassada inside the station's cupola. However, regardless of the solar array status, several capture windows were already built into the timeline today, and Mann and Cassada relayed to Mission Control that they are ready. Joining me here today in Mission Control Houston is Jeff Aaron from the International Space Station program. Jeff, thank you for joining us today here to talk Cygnus.
Thank you very much, Chelsea. I'm happy to be here. It's awfully early, though.
Yes, indeed. So, Jeff, how have NASA and Northrop Grumman teams worked together to plan for today's rendezvous process?
You know, at some level, the way the teams are working together, it's almost exactly the way we've worked on all of our previous missions. Of course, the one big difference is kind of what you've already mentioned, that we normally have two fully deployed arrays that allow us to execute our nominal mission with a fair bit of margin to deal with unexpected anomalies. In this case, the unexpected anomaly occurred very shortly after the mission started, and obviously that's the wing that didn't deploy. This quickly got the teams into discussions about further attempts to deploy the array, kind of as you pointed out, but then you kind of introduce consequences of a partially deployed array, and then the teams also quickly got into a discussion about our confidence in mission success operating with only one array, which is kind of where we are right now.
And what did NASA take into consideration for today's rendezvous of a spacecraft in an off-nominal configuration?
So, as you pointed out, we didn't even coordinate this, but we actually did a pretty good job coordinating this. After multiple attempts to deploy the solar array wing number 2, the focus shifted to power management to ensure the Cygnus batteries will have sufficient capability to support rendezvous, as well as the health of the remaining Cygnus systems. The NG team assessed multiple mission power profiles against their phasing and approach procedures and demonstrated positive margins in all cases. They also looked at system components that we could consider powering down to provide some additional margin to the system. There's some fans and there's some other telemetry that we can actually do without, and those are the kind of things that we could actually turn off. Getting back to the health of the systems, the remaining Cygnus systems, basically the whole vehicle gets exercised multiple times from solar array deploy until it gets in close proximity to the ISS. So through about 7 p.m. last night, the vehicle executed 8 phasing burns. One of which we call DV4, is a large burn. It's 50 meters per second. It takes 14 minutes to execute, so the spacecraft really has to operate well for us. These burns require what I call all the brains and propulsion assets of Cygnus, and they were all executed flawlessly.
Cable connection. Do I have a go?
So, Jeff, I mentioned earlier that we're going to be taking some additional imagery of Cygnus. What will teams be looking for in any inspections as Cygnus gets closer to the station?
Thank you.
Yeah, Yeah, no, that's a good point. So the teams will be looking at what I would call the overall health of the vehicle, certainly keeping a keen eye on wing number 2. Our best data tells us the array is in a structurally safe configuration, but confirming this with video is always reassuring. The video data can also demonstrate to us that Cygnus's attitude control system and laser ranging systems are performing nominally. And of course, as we always do, we'll inspect the passive control or berthing mechanism just to make sure it's clean before we actually attach it to the Node 1 Unity module.
Jeff, Aaron, thank you so much for joining us.
Yep, happy to be there. Thanks very much. You're too kind, Rob.
Pre-approach initiation burn complete. Expect to begin using 1.102 Cygnus approach and retreat monitoring shortly when Cygnus range reaches 1,000 meters.
Agent copies.
Cygnus is now within the vicinity of the space station. Before our coverage today, Cygnus successfully completed 4 rendezvous burns, and the teams also pulled go to enter into joint operations. Now that we're in joint operations, all decisions regarding the Cygnus cargo spacecraft must be approved by today's flight director here in Mission Control Houston, Chloe Maring. We're now just about an hour and a half away from our estimated capture time. Cygnus also went on to complete 2 ADV burns, or approach delta velocity burns, number 1 and 2. These are rendezvous burns that fine-tune Cygnus's path, and teams pulled go to continue on for 2 more ADV burns. After pulling go for these 2 more burns, ADV burn number 3 has been completed. Once again, this is a rendezvous burn to fine-tune Cygnus's path. These burns will bring Cygnus from 1,000 meters directly below the space station to about 500 meters in front of the space station, where it can begin its final approach. Going on from there, it has a number of built-in holds at various distances away from the space station. At those hold points, Northrop Grumman and Mission Control Houston, as well as the astronauts on the space station, will confirm that they're good to continue, and Cygnus will continue on towards the space station. On your screen now is a live view of the Cygnus cargo spacecraft. It's very tiny right now and on the left-hand side of the pink circle. It'll continue to get bigger and bigger as it approaches the space station. Right now it is within 1,000 meters of the International Space Station, closing in.
Station Houston on 2. Cygnus range is 1,000 meters. Monitor long-range approach per step 1 in 1.102. Cygnus approach and retreat monitoring.
Station copies 1.102, step 1, and we've got it in sight.
Houston copies.
Cygnus is now within 700 meters of the International Space Station. You can see it pretty small right now on your screen as it's making its approach to the International Space Station. The third approach delta velocity burn is complete, and the space station is flying over the South Indian Ocean. Cygnus is now it's still in a dynamic event, and we're going to continue to monitor, but as of now, it's pretty much on track for capture at 4:05 a.m. Central Time. NASA astronauts Nicole Mann and Josh Cassada are inside the station's cupola. They have eyes on the Cygnus cargo spacecraft, and that from within the cupola is where NASA astronaut Nicole Mann will use the space station's Canadarm2, the SSRMS robotic arm, to grab onto Cygnus. And right now we're on time. We're heading towards an on-time capture at 4:05 a.m. Central Time. The Cygnus cargo spacecraft is now within 600 meters of the International Space Station. The teams here in Mission Control have reported a good ADV-3 burn. That's the approach delta velocity burn, and Cygnus has passed through the approach ellipsoid. Cygnus is now within 500 meters of the International Space Station, and we are in a brief but expected handover of our communication satellites. We expect to get live views of the Cygnus cargo spacecraft back momentarily. We're back with you now with live views of the Cygnus cargo spacecraft as the International Space Station is flying over the Indian Ocean. So Cygnus has passed through the approach ellipsoid. This is a three-dimensional ellipsoid. It's an imaginary line around the International Space Station measuring 4 kilometers by 2 kilometers by 2 kilometers. Basically, with the approach ellipsoid, vehicles outside of it have to be on what we call a 24-hour safe free drift trajectory. This means the spacecraft will not cross into the approach ellipsoid for at least 24 hours in the event that we lost all maneuvering of the spacecraft. Cygnus is now within 400 meters of the International Space Station. To recap once again the events of these last couple of days, about 3 hours after Monday's launch of Northrop Grumman's Antares rocket, the command was sent to the Cygnus cargo spacecraft to deploy the solar arrays. One deployed nominally and generated power for the spacecraft. One did not and is in a partially staged configuration or partially deployed. Efforts to fully deploy it have been unsuccessful. However, it was deemed that the Cygnus cargo spacecraft does have enough power on the one solar array to make it to the International Space Station. This is an incredibly dynamic event, and we're continuing to have eyes on the cargo spacecraft. You can see it on your screen now on the right-hand side of that pink circle, and it's continuing to make its approach to the International Space Station, having successfully gone through a number of rendezvous burns, and is proceeding nominally towards the space station. It is now 340 meters away. the International Space Station now crossing over the southern coast of Australia. NASA astronauts Nicole Mann and Josh Cassada are inside the cupola with views of the Cygnus cargo spacecraft, getting ready to capture the spacecraft at 4:05 a.m. Central Time. Cygnus is carrying 8,200 pounds of cargo to the International Space Station, on top of numerous science experiments. It's also carrying a mod kit for an upcoming spacewalk on November 15th for the 1B power channel for future solar array installation.
Houston Station on 2. Initial photos are on SSC 11, and we'll keep them coming.
Houston copies, SSC 11.
He just heard the voice of NASA astronaut Josh Cassada relaying that they're taking some imagery of the Cygnus cargo spacecraft. That was planned as teams want to get a better understanding of the solar arrays and with the eyes from the astronauts on the space station. Josh Cassada was talking to Capcom Rebecca Tidman here in Mission Control Houston. Cygnus is now less than 300 meters away from the International Space Station. At the 250-meter point, Cygnus may go into a planned hold. This is where Northrop Grumman, the team here in Mission Control Houston, as well as the astronauts aboard the International Space Station inside the cupola, will just confirm that everything is good on their side before Cygnus can proceed. The Cygnus cargo spacecraft, live on your screen now with views from the International Space Station, is now 275 meters away as the International Space Station is moving off the northern coast of Australia, about to enter an orbital nighttime. You can see a great view on your screen now of the Cygnus cargo spacecraft moving into that orbital nighttime. You can see the difference between the right side of your screen and the left side of your screen. It's preferred that Cygnus is captured during a daytime, and the first capture window does indicate that. However, it is possible to catch Cygnus in an orbital nighttime using lights on the end of the SSRMS Canadarm2 robotic arm. Couple of milestones to look forward to during capture. At the hands of NASA astronaut Nicole Mann, she'll use the station's robotic arm to grab onto the grapple fixture on Cygnus. We may have views looking down the robotic arm as it happens. Once captured, the snares at the end of the latching end effector, or the lee, will close around the grapple fixture. Nicole Mann will then slowly maneuver the Cygnus cargo spacecraft to the Earth-facing port towards the common berthing mechanism on the Earth-facing port of the Unity module. From there, she'll hand over operations to our robotics officers here in Mission Control, who will work to install the Cygnus cargo spacecraft. And Cygnus is now at the 250-meter mark. Well, it will go into its planned hold.
Station Houston on 2, confirm Cygnus 250-meter hold per step 2 and 1.102.
Station copies. We've got a Cygnus command panel LED status as expected, and we have a pry range of 252.1. And for Block Bravo Monitor 1, the light is in the corridor, and the vehicle size is too dark to measure. The light is inside the circle, and the circle is centered in the corridor.
And Josh, can you clarify if that's on both cameras?
Same on both monitors 1 and 3.
Houston, copy, thanks. And Station Houston, on 2, back with you, Josh. I do have one item I wanted to bring your attention to. We've been tracking some issues with LiDAR 2, and it did finally fail out. We do have a good LiDAR 1 and 3, but if we lose either LiDAR 1 or 3 at this point, it would trigger an automatic abort. How copy?
Okay, Rebecca, I appreciate the heads up. LiDAR 2 is down, and if we lose either 1 or 3, we'll get an automatic abort. Copy.
That's a good copy.
And Station Houston on 2, just to confirm, that would be an automatic abort or an automatic retreat?
And Josh, that's an automatic abort.
Okay, just want to be clear. Thank you.
You just heard some words exchanged between Capcom Rebecca Tidman and NASA astronaut Josh Cassada, who is in the cupola, about Cygnus's LiDAR systems. LiDAR is a navigation sensor system on Cygnus that measures range from the International Space Station and the rate of closure. They have 3 of these sensors, and they need 2 to have redundancy to keep going. Capcom Rebecca Tidman conveyed that if one more LiDAR sensor fails, Cygnus will make an automatic abort and not continue towards the space station for capture. That's not the case right now, and they're at the 250-meter hold point to assess. Again, this is between the astronauts with eyes on Cygnus, Mission Control Houston, and the Cygnus Flight Control team over in Dulles, Virginia, and are still working for a capture during the first window.
Station Houston on 2. Cygnus and ISS are configured for approach inside the keep-out sphere. Expect approach to resume shortly and stand by for the Cygnus PCS command checkout.
Station copies.
Capcom Rebecca Tidman just conveyed to the astronauts aboard the International Space Station that we are go to proceed past the 250 hold point. The next hold point is expected at 30 meters away from the International Space Station. Cygnus is now at 250 meters away and is about to begin movement.
Station Houston on 2. Cygnus has resumed approach. Go for Cygnus PCS command checkout. Hold arm for step 3 and 1.102.
Copy. We're go for step 3 of 1.102.
Cygnus has now moved past its 250-meter hold point. As the International Space Station was flying over the Pacific Ocean, it's now within 225 meters away from the International Space Station and closing in.
Command is actually armed and flashing.
Houston, copy. Okay, Josh. Hold arm is confirmed. Go for Cygnus PCS command checkout. Disarm per step 4 in 1.102.
Okay, copy. Step 4 in work.
The next expected hold is at the 30-meter hold point, at which point Cygnus will stop inching towards the International Space Station, and flight controllers here in Mission Control and over at Northrop Grumman's Dulles facility, as well as the International Space Station astronauts, will confirm and give a no-go pull to depart that 30-meter hold.
Houston Station, hold arm is now steady. Houston Station on 2, did you copy that hold command is disarmed and hold arm is now steady?
And Houston copied. All right, Josh. Cygnus PCS command checkout was successful. Begin monitoring approach from 250 meters per step 5 and 1.102. And on top of that, Cygnus is inside the 200-meter keep-out sphere. Crew now has the authority to issue an abort if no comm with MCCH, and the light is outside the corridor.
And we copy. Thanks, Rebecca.
Live on your screen now is a view from Mission Control Houston. That is Flight Director Chloe Mering, closest. And then in the foreground, we have Capcom Rebecca Tidman, who you just heard communicating with the crew.
Light is inside the circle, and the circle is offset from the center of the corridor by 1 vehicle width. To the starboard. And for monitor 3, all the same.
Houston copies. Thank you, Josh.
Cygnus is now within 150 meters of the International Space Station.
Grumman station on 2, no change to Block Bravo for monitors 1 and 3.
Houston copies.
Cygnus is continuing to make its approach, now 120 meters away from the International Space Station. We're in another brief but expected hold of communication satellites. You're getting a live view of Mission Control Houston. Cygnus is continuing to make its approach, going towards that 30-meter hold point, at which point it will stop, and the control rooms in Dulles, here in Houston, and the astronauts aboard the International Space Station will give a go, no-go, see if they're ready for capture. Cygnus is going to continue to move to its capture point about 10 or 11 meters away from the International Space Station, where it'll be grabbed by NASA astronaut Nicole Mann using the robotics workstation in the cupola. She'll use the Canadarm2 to grab onto the grapple fixture of Cygnus. At the end of the Canadarm2 is what you may hear referred to as the lee, or the latching end effector, which is basically the hand of the arm. Inside are latches and snares that can grab onto and capture today's target. The latching end effector does have a camera, so we may get views from the robotic arm itself when Cygnus gets a little bit closer.
Station Houston on 2 with an updated T2 exercise constraint.
Go ahead, Rebecca.
Hey, Josh. We just noticed that the no T2 exercise constraint on the crew bands at 10:10 is not reflected correctly on your timeline. It should extend all the way in between those two no exercise blocks. So it should extend all the way until you hit the no exercise at 11:40. So no T2 at all in that time frame.
Okay, we copy and we pass the word. Thank you.
The view you're seeing now is from inside the cupola of the International Space Station. This is the interface that NASA astronauts Nicole Mann and Josh Cassada, monitoring today's operation, are seeing as well. So even though we're in an orbital nighttime and it's difficult to see Cygnus, they still have all the data available to them. To make some sense of the numbers that you're seeing, if you look on the right-hand side of your screen, the bottom set of numbers says VV to ISS, as well as the range rate. We're about 88. That means Cygnus is 88 meters away from the International Space Station and closing in.
Houston station on 2 for Block Bravo. Monitor 1, the light is inside the corridor. Vehicle size is still too dark to measure. The light is inside the circle, but just on the edge, on the aft edge of the circle. And the circle is offset starboard half a width from the center of the corridor. For monitor 3, all the same except for the light is on the starboard edge of the circle.
Houston copies all.
Cygnus now within 75 meters of the International Space Station.
Houston station on 2 for Block Bravo update. The only change here is monitor 1. The aft light is just outside of the circle, aft of the vehicle. And of course the forward light is inside the circle, so the circle splits the two lights.
Houston copies. That's all nominal.
Cygnus now within 60 meters of the International Space Station, heading to its 30-meter hold point.
Houston Station on 2 at 50 meters, no updates to the block Bravos. They remain unchanged.
Houston copies.
Cygnus is now 45 meters away from the International Space Station as the station is flying over Michigan. Again, we're going towards that 30-meter hold point. It's a live view of the Cygnus cargo spacecraft on your screen now. It's hard to see as we're in an orbital nighttime. We're about 3 minutes away from a sunrise. Now just over 35 meters away from the International Space Station. That city down below you see, the International Space Station is crossing over Maryland, headed over Delaware.
Houston Station on 2 for Monitor 3, Block Bravo. The light is inside the corridor. The vehicle size matches the outline, and the light is just starboard of the circle, and the circle is centered in the corridor. Monitor 1 right now, just a little too bright of the light itself, but vehicle matches the outline.
Houston copies. And Station Houston on 2, confirm 30-meter hold and set up for capture for step 6 and 1.102.
Houston copies, pick it up in step 6. Houston Station for step 6, we confirm that the mode is hold and primary range is 30.32.
All right, Houston copies.
Cygnus has reached its 30-meter hold point. You can see the astronaut zooming in to allow flight controllers to get a better look of the Cygnus cargo spacecraft. You can see the top solar array is deployed, while the bottom one is in a partially staged configuration, partially deployed. Teams in mission control are going through a go, no-go poll to proceed through the 30-minute hold point now.
Houston Station on 2, third round of photos on SFC 11 again.
All right, great. Thanks, Josh. And for your awareness, we couldn't see the second round, but we'll take another look now that you've got this third round out there.
Okay, copy. Description that I put in there was NG-18, and then for the second round, NG-18-2, and then the third one, NG-18-3.
All right, we copy.
We're now moving into an orbital daytime, and now that the astronauts are getting a good look at Cygnus, now that it's stopped at its 30-meter hold point, NASA astronaut Josh Cassada is working with the ground on some imagery to get a better idea of what's going on with the Cygnus cargo spacecraft. It's performing nominally so far. They just want to understand a little bit more about the solar array that is partially deployed. That would be the one on the bottom of the screen. Here at the 30-meter hold point, Mission Control Houston going over roles and responsibilities in the unlikely event of the contingency, who would do what and at what point. Meanwhile, Cygnus is still at its 30-minute hold, and teams will do a go, no-go poll to proceed. We are now within 20 minutes of our estimated capture time. After this 30-meter hold point, Cygnus will be expected to inch closer to the International Space Station, stopping at its capture point. This won't be at 0 meters away, but rather 10 to 11, which gives NASA astronaut Nicole Mann enough room to capture Cygnus using the robotic arm. Inside that spacecraft that you see on your screen now is 8,200 pounds of cargo making its way to the International Space Station. This includes fresh fruits and veggies and holiday treats for the crew, but more importantly, has scientific experiments and hardware going up for future spacewalks to install the IROSA rollout solar arrays. Specifically, we've got the mod kit for the 1B power channel. This is not a typical configuration for Cygnus. You see the topmost solar array fully deployed. The bottom one that you see on your screen is only partially deployed. The Ultraflex solar arrays did not fan out on that one. That's why teams want to be extra careful going into this operation, but so far everything is proceeding nominally, and teams are reviewing imagery from NASA astronaut Josh Cassada that he took as the International Space Station was in orbital daytime with the Cygnus cargo spacecraft 30 meters away from the International Space Station.
Station Houston on 2. We're just looking for a status on the capture setup. If you need more time to continue reviewing the cue cards, you're more than welcome to take it.
And station copies. The crew is ready for Cygnus approach to capture point.
And Station Houston on 2, we are not seeing that the SSRMS safing is removed from step 3.1 of 1.110 Cygnus capture.
Thank you very much. Yeah, our review is complete, and we're executing 3.1 now.
Houston copies.
Cygnus is still in its 30-meter hold point, 30 meters away from the International Space Station. The astronauts aboard the station inside the station's cupola are going through their steps.
Houston Station on 2, step 3 is complete and ready for step 4 when we've got to go.
All right, Houston copies. Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies.
And we are a go for final approach. Cygnus has begun moving through the 30-meter hold point, heading towards about 10 to 11 meters away from the International Space Station for NASA astronaut Nicole Mann to use the robotic arm to grab onto the grapple fixture on Cygnus.
1.102.
This comes after a go, no-go poll.
High range less than 6 meters.
Station copies and understand step 7, 1.102.
After Cygnus reaches its capture point, again 10 to 11 meters away from the space station, another go, no-go poll will be completed for capture. This is between the astronauts on the space station, Mission Control Houston, and Cygnus's flight control team over in Dulles, Virginia.
Houston Station on 2 for Block Bravo. Just a heads up, it's real hard to pick out the white light on either monitor 1 or 3, but the light is definitely inside the corridor and the vehicle matches the outline. And the circle itself is centered within the corridor on both monitors 1 and 3.
Houston copies, nominal report.
Even though Cygnus is heading for its capture point, once it reaches that capture point, it does not automatically mean that astronaut Nicole Mann is going to use the robotic arm to actually capture it. A lot of steps need to be completed in between. For instance, there's that go, no-go poll we just talked about, and they'll also turn off the DSATs. Basically, the astronauts will be inhibiting any thrusters on the station from firing. These are automatic thrusters, and once Cygnus is grappled, they don't want those going off and interrupting this operation. When that happens, you may hear a call from station to the ground saying that DSATs are inhibited. We are now less than 15 minutes away from the estimated capture time of the Cygnus cargo spacecraft. However, there's plenty of room within that first capture window and plenty of capture windows after that if necessary. Cygnus is now less than 20 meters away from the International Space Station.
Houston Station on 2 inside of 16 meters and no changes to the block Bravos.
Houston copies.
Cygnus now within 15 meters of the International Space Station. On your screen now you can see the Cygnus cargo spacecraft, and on the left is the Canadarm robotic arm that will be used to capture Cygnus today.
Houston Station onto, not sure if you ended up getting the second and third rounds of photos, but just a heads up, that grapple picture looks solid. It looks great.
Houston copies. We did get those photos, and we concur on the fixture.
Cygnus has reached its capture point and a go-no-go poll is underway.
Station Houston on 2. Confirm capture point hold per step 8 and 1.102.
Station copies. 8 is complete and capture conditions are confirmed and crew is ready for Cygnus capture.
Okay, Josh, and before we proceed, I wanted to give you a status. We are seeing some weather in Guam, and we expect that we might get some radicom on this pass that we're on right now. With that said, you are primed for everything, so we are go ahead and stand by for capture.
Copy on the comm, and we're standing by at 4.1.
Station Houston on 2. Go for Cygnus capture sequence. Step 4 in 1.110 Cygnus capture. Begin monitoring the back-away cue card.
Station copies. We are go for Cygnus capture.
At 12 meters away from the International Space Station, Cygnus is at its capture point, and the teams of Northrop Grumman and Mission Control Houston have pulled go to proceed with capture. Around the time of capture, you'll hear a call for first stage capture, but it won't be until the snares close around the grapple fixture that will relay the official time of capture. So taking a look at your screen here, you'll see a circle towards the bottom of Cygnus, and then a long horizontal bar just on top of that. That long bar is the grappled target. NASA astronaut Nicole Mann is aiming for that line and using it as a guide. They're lining up the arm with that, so just below the fixtures will actually interact with that circular pinwheel shape on the bottom to grab onto Cygnus. And we did hear that the DSATs are inhibited. Once again, these are fueled thrusters that can autonomously fire if the International Space Station goes outside of its orientation, and we don't want them to go off when the robotic arm grabs onto Cygnus, so these are disabled. Now just under 3 minutes until capture. And we have confirmation that the SSRMS robotic arm on the International Space Station is moving. slowly but surely, that SSRMS robotic arm is making its way towards Cygnus, locked onto the grapple target. The arm is 2.5 meters away from Cygnus. One meter away. We have capture and are standing by for snares closed. And these snares have closed. Basically, the hand of the robotic arm has closed its fingers around the grapple fixture. The Cygnus cargo spacecraft supporting Northrop Grumman's 18th commercial resupply services mission was successfully captured at the controls of NASA astronaut Nicole Mann using the station's robotic arm at 4:20 a.m. Central as the International Space Station was flying over the Indian Ocean. Cygnus took a 2-day journey to the International Space Station after its launch. A couple hours after launch, teams were unable to deploy one of the 2 solar arrays, and after much review and analysis, Cygnus was successfully able to be captured by the station's robotic arm at 4:20 a.m. Central, 5:20 a.m. Eastern Time.
We certainly agree with her. That from Leo. The stars do not look bigger, but they certainly look brighter. A huge congratulations to the NG-18 team for their tireless efforts in getting Sally Ride to the ISS and for a successful capture today. You have a go for Cygnus post-capture reconfiguration.
Houston copies all. Excellent work, Duke and Josh, and welcome to the ISS SS Sally ride. We want to reiterate the heartfelt congratulations to the NG team on behalf of MCC Houston, and we're all very happy to see Cygnus finally captured.
Some kind words there from NASA astronaut Nicole Mann after the successful capture of the Cygnus cargo spacecraft, welcoming the SS Sally ride to the space station. Next up, robotics officers here on the ground will align Cygnus's common berthing mechanism with the common berthing mechanism on the Earth-facing port of the Unity module and work to bolt it into place. At this point, NASA astronauts Nicole Mann and Josh Cassada are relieved from their duties at the robotic workstation inside the station's cupola and are going to go on about the rest of the tasks for their day. Before Cygnus is berthed to the International Space Station a couple hours from now, the team is going to continue to take some imagery of the Cygnus cargo spacecraft to understand a little bit more about what was going on with that solar array. You're getting a live view of mission control. Teams here, as well as the Northrop Grumman team over in Dulles, Virginia, worked diligently these past 2 days to get the SS Sally ride to the International Space Station after an unsuccessful solar array deployment by one of the wings. Cygnus was able to be robotically captured at the hands of NASA astronaut Nicole Mann at 4:20 a.m. Central Time, 5:20 a.m. Eastern Time. For now, teams are going to do some checkouts of the Cygnus cargo spacecraft and then turn over controls over to our robotics officer here in Mission Control, who will work to berth Cygnus and install it to the Earth-facing port on the Unity module. We'll be back on with coverage of installation at 6:15 a.m. Central Time. This is Mission Control Houston.